Mars, the red planet, has captured our imaginations for centuries. Its mysterious, dusty surface and the possibility of life have always intrigued scientists and dreamers alike. It represents the ultimate frontier, a new world to explore and conquer. The idea of humans setting foot on Mars, leaving their footprints on its red soil, is a powerful symbol of our quest for knowledge and adventure. Colonizing Mars is a dream that many share, a vision of humanity spreading beyond Earth. Imagine thriving colonies with domes and greenhouses, where people live and work, creating a new chapter in human history. But this dream comes with significant challenges. The harsh Martian environment, with its dust storms and extreme temperatures, poses a constant threat to both equipment and human life. The journey is perilous, the environment unforgiving, and the task of building a self-sustaining colony daunting. Navigating the rocky terrain and setting up essential infrastructure like solar panels are just the beginning of the hurdles we face. Before we take this giant leap, we must carefully consider the risks involved. Every decision must be meticulously planned, with mission control and scientists working tirelessly to ensure the safety and success of the mission. Can we overcome the technological hurdles? Engineers and scientists are constantly innovating, testing new technologies and prototypes to make Mars colonization a reality. Can humans adapt to such an alien environment? Training and preparation are crucial, as astronauts must learn to survive and thrive in conditions vastly different from Earth. And perhaps most importantly, is it ethically responsible to attempt such a feat? The debate among scientists and ethicists continues as we weigh the potential benefits against the moral implications of colonizing another planet. The allure of Mars is undeniable. Its stunning landscapes and the promise of new horizons captivate our imagination and drive our ambitions. It holds the promise of scientific discoveries, of pushing human ingenuity to its limits, and of securing the future of our species. Analyzing rock samples and cultivating plants in Martian soil could unlock secrets that benefit all of humanity. However, we must proceed with caution, fully aware of the potential pitfalls that lie ahead. Every step forward must be taken with a deep understanding of the risks and a commitment to overcoming them, ensuring that our dream of Mars becomes a sustainable reality. The journey to Mars is one of the biggest challenges we face. It's a mission that pushes the boundaries of human ingenuity and endurance. The distance between Earth and Mars varies greatly depending on their orbits. At times, they are on opposite sides of the Sun, making the journey even longer. At their closest, they are about 34 million miles apart. This distance is vast, and traveling it requires precise planning and timing. Even with current technology, a one-way trip to Mars would take approximately 7 months. This duration is filled with numerous challenges and uncertainties. Confining astronauts to a cramped spacecraft for such a prolonged period poses numerous risks. The psychological strain of isolation and confinement is significant. Muscle and bone loss due to prolonged weightlessness is a major concern. Astronauts must exercise regularly to mitigate these effects, but it's not a perfect solution. Additionally, the spacecraft would be bombarded with harmful cosmic radiation throughout the journey, increasing the risk of cancer and other health problems. This radiation is a silent, invisible threat that requires serious countermeasures. Protecting astronauts from radiation is a significant technological hurdle. Engineers are constantly developing new materials and methods to shield the crew. Shielding materials are heavy and add to the spacecraft's mass, making it even more challenging to launch and propel through space. Every additional pound of shielding requires more fuel and more powerful rockets. Finding a balance between effective shielding and spacecraft weight is crucial. This balance is a delicate one, requiring innovative solutions and constant testing to ensure the safety and success of the mission. Upon arriving on Mars, the challenges only multiply. The journey itself is just the beginning of a series of daunting obstacles that await human explorers. The Martian environment is incredibly hostile to life as we know it. The landscape is barren, with frequent windstorms that can last for days, making navigation and communication difficult. The atmosphere is thin, composed primarily of carbon dioxide, making it unbreathable for humans. This means that astronauts must rely on life support systems to provide the necessary oxygen. Temperatures on Mars are extreme, with an average surface temperature of -63 degrees Celsius. The cold is relentless, and it poses a significant risk to both human life and equipment. These temperatures can plummet even lower during Martian nights, reaching levels that can freeze exposed skin and damage unprotected machinery. The lack of a substantial atmosphere also means there's little protection from the sun's harmful radiation. This radiation can cause severe health issues, including cancer, making shielding a top priority. Water, essential for human survival, is scarce on Mars, existing primarily as ice beneath the surface. Finding and accessing this ice is a complex task that requires advanced technology. Extracting and utilizing this water will be crucial for any long-term human presence. Innovative machinery and techniques are being developed to make this process efficient and sustainable. Overcoming these environmental hurdles will require innovative solutions and significant technological advancements. Scientists and engineers are working tirelessly to develop habitats, life support systems, and other technologies that will enable humans to not just survive, but thrive on Mars.